Hey y'all, today is April 11th and I'm going to work out the basic skills assessment practice. So this is your study guide for your BSA number 15 quiz that you have tomorrow, April 12th. So on this quiz, you're going to see 7 questions related to scale drawings where you set up a proportion and you cross multiply to solve. And then you're going to see another 7 questions related to triangles. So let's get started with our scale drawings. So number 1, Carla made a model of the Eiffel Tower using a scale of 4 inches equals 60 feet. If the Eiffel Tower is 984 feet tall, how tall is her model? And on your quiz, this question would be worth 3 points. So every single one of these has a points value next to it, and that's just so you know how many points it would be worth. The whole quiz tomorrow will be worth 40 points. So let's get started. Important information that I would highlight here is the scale is 4 inches equals 60 feet. Okay, we also know that the Eiffel Tower in real life is 984 feet tall. So remember, we set this up as the model over the actual. So I know that the model is measured in inches. So we have 4 inches over 60 feet. And it's important that I include my units here because this tells me that I want to have my inches all on top and feet all on the bottom. Okay, so now we're going to have a second fraction, and the only other measurement I know is 984 feet. So because it's feet and I keep feet on the bottom, I'm going to put 984 on the bottom. Okay, and then I'm going to put an X on top. That's the value that I'm trying to find. How tall is her model? So now I'm ready to cross multiply. Well, 60 times X is simply 60X. And I set that equal to 4 times 984, which if you put that into your calculator, you get 3,936. Now to get that X by itself, we divide by 60 on both sides. So my 60s cancel out. X is indeed by itself, and 3,936 divided by 60 is 65.6, but I need to include my unit. So remember, because my X was on top and my inches were on top, I know it's inches. So the model is 65.6 inches tall. Okay, let's move on to number 2. So the scale on a map reads ½ an inch equals 85 miles. If the distance between 2 cities on the map is 3 3/4 inches, find the actual distance between the cities. So important information here is ½ an inch equals 85 miles. And we know that 2 cities on the map are 3 3/4 inches apart. Okay, so remember it's model over actual. And one thing I noticed is that I've got fractions here. So I would be putting fractions in fractions, and I really don't like that. So I'm going to change them to decimals. So ½ an inch I know is 0.5. So my first fraction is going to be 0.5 over 85. And remember, it's 0.5 inches to 85 miles. And I'll set that equal to a second fraction. And the only other measurement I know is 3 3/4 inches. So where does it need to go? Well, my inches have to all be on top. So it needs to go right here. Now, 3 3/4. Well, I know that 3 divided by 4 is 0.75. So it's going to be 3.75. So 3.75 inches, and we don't know how many miles that represents. We've got to figure that out. So now I'm ready to cross multiply. So 0.5 times X is 0.5X. And I set that equal to 85 times 3.75. And if I put that into my calculator, I get 318.75. 318.75. So now I'm ready to get that X by itself. To do that, I need to divide by 0.5 on both sides. So my 0.5s cancel out. X is indeed by itself. And 318.75 divided by 0.75, if you put that into your calculator, you get 637.5 miles. So that's how far apart those cities are in real life. That's the actual distance between them. Okay, let's move on to number 3. A model of a helicopter is made using a scale of 1 inch equals 4.375 feet. What is the actual length of the helicopter if the model is 8 inches long? Okay, so important information. We know that the scale is 1 inch equals 4.375 feet. And we also know that the model is 8 inches long. Okay, so the scale is what I'm going to use to write my first fraction. So I'm going to have 1 over 4.375. Now notice it's 1 inch over 4.375 feet. Including my units helps me remember that I'm keeping inches on top and feet on the bottom. And the only other measurement I know is 8 inches. So where does the 8 go? It needs to go on the top. And we're trying to find the actual length of the helicopter. So now I'm ready to cross multiply. We have 1 times x, which is simply 1x or just x, equals now 4.375 times 8. And if you put that into your calculator, you get 35. So x equals 35, but 35 what? Well, because my unit on the bottom is feet, I know it's 35 feet. Okay, moving on to number 4. On a map, 3 centimeters represents 45 miles. The actual distance between 2 towns is 105 miles. What is the distance between them on the map? Okay, so important information that we know, 3 centimeters represents 45 miles. I'm going to use that to make my first fraction. And I also know that the 2 towns are 105 miles apart in real life, right? Okay, so like I said, I'm using 3 centimeters represents 45 miles to make my first fraction. So 3 centimeters on top and 45 miles on the bottom. And I want to set that equal to a second fraction. And the only other measurement I know is 105 miles. So because it's miles, it's going to go on the bottom. So 105 goes on the bottom, and I'm trying to figure out how far apart those cities are on the map. So now I'm ready to cross multiply. 45 times x is 45x. And I set that equal to 3 times 105, which is 315. Now to get that x by itself, I'm going to divide by 45 on both sides. So my 45s cancel out, x is by itself, and 315 divided by 45, if you put that in your calculator, you get 7. 7 what? Well, remember, my unit on top is centimeters. So 7 centimeters is my answer. Okay. Moving on to number 5. Xavier makes a scale drawing of his backyard. The scale from the backyard to the drawing is 4 feet to 1 inch. The width of the patio on the drawing is 5 inches. What is the width of Xavier's actual patio? Okay, so what we know is from the backyard to the drawing is 4 feet in real life to 1 inch in the drawing, right? And we know that the width of the patio in the drawing is 5 inches. Okay, so usually we set this up as model to actual, but it really doesn't matter as long as you keep your units on the top and bottom the same. So because it was written as 4 feet to 1 inch, I'm just going to do it that same way. So 4 feet over 1 inch. So this is telling me that my feet need to be on top and my inches need to be on the bottom, right? So the only other measurement I know is 5 inches. So because it's inches, I'm going to put it on the bottom, and I'm trying to figure out the feet on the top. So now I'm ready to cross multiply. 1 times x is 1x, or just x. And then 4 times 5 is 20. Now what is my unit on the top? It's feet. So 20 feet is my answer. So that is the width of Xavier's patio in real life, 20 feet. Okay, number 6. A scientist who studies insects enlarges a photo of an elm leaf beetle. Every 2 inches in the photograph represents 8 millimeters on the actual beetle. The width of the beetle in the photograph is 3/4 inches. What is the width of the actual beetle? Show your work. Okay, so important information. 2 inches in the photograph represents 8 millimeters on the actual beetle, right? So 2 inches equals 8 millimeters. I'm going to use that to make my first fraction. So 2 inches equals 8 millimeters. So this is telling me that my inches need to go on top and my millimeters need to go on bottom. Now the only other measurement that I'm given is that the width of the beetle in the photograph is 3/4 of an inch. Well, because it's inches, where does it go? It's going to go right here on the top. Now, I really don't like fractions and fractions, so how can I rewrite it so it's not going to be a fraction and a fraction? Let's make it a decimal. 3 divided by 4 is 0.75, so we've got 0.75 inches, and we're trying to figure out the millimeters, the actual width of the beetle. So now we're ready to cross multiply. 2 times x is 2x, and I set that equal to 8 times 0.75. And 8 times 0.75 is 6. So now to get that x by itself, we divide by 2 on both sides. 2's cancel out. X is by itself. 6 divided by 2 is 3. 3 millimeters is the actual width of the beetle. Okay. Now number 7. So the scale from a playground to a scale drawing of the playground is 4 meters per 1 centimeter. The length of the drawing of the playground is 5.3 centimeters and the width is 3.8 centimeters. What is the area of the actual playground? So this one's a little different because we have to find area. So I want you to remember that we find area by multiplying length times width. So I'm going to have to figure out what is the real life actual width and real life actual length of the playground. Okay, so important information to start with. We know that the scale is 4 meters per 1 centimeter. Okay, now it doesn't matter if we do it as model over actual or actual over model, as long as we're consistent. So we're going to start by finding our length first, finding our actual length, and we're going to use the scale. And because it's written as 4 meters per 1 centimeter, I'm going to put 4 on top, 4 meters on top, and 1 centimeter on the bottom. Okay, so my meters are going on top, my centimeters are going on the bottom. If you did it as 1 centimeter over 4 meters, that's perfectly fine, as long as you're consistent with where your units go. Okay, now, looking at our playground, I'm going to consider this right here my length. So my length is 3.8 centimeters, okay? So centimeters, where does it go? It goes on the bottom. So 3.8 down here, and that means we put x on the top. So now I'm ready to cross multiply. We have 1 times x, which is 1x or just x, and 4 times 3.8. And 4 times 3.8, if you put that into your calculator, you get 15.2. So 15.2 meters is the length of the playground. Now we're not done yet. Okay, next we have to find the actual width of the playground. So our scale is the same. So I'm going to use this same fraction right here. So we have 4 meters over 1 centimeter. If you wrote it as 1 centimeter over 4 meters, that's perfectly fine as long as you're consistent with your units. Okay? Now, our width is the measurement that we haven't talked about yet. So we've already talked about 3.8. So that means that 5.3 is our width. So 5.3 centimeters is the width. Well, centimeters goes on the bottom. So 5.3 down here and x up here. Now I'm ready to cross multiply. 1 times x is 1x or just x. And I set that equal to 4 times 5.3. And if I put that into my calculator, I get 21.2 meters. Hold on, because we're not yet done. My next step is to calculate the area. So area we know is length times width. So our length that we found was 15.2. And our width that we found was 21.2. So 15.2 times 21.2. If I put that into my calculator, I get 322.24. And it would be meters squared, or squared meters. So 322.24 square meters. That is the actual area of the playground. Okay, so that's it for scale drawings. Let's move on to our 7 questions about triangles. Okay, so the blank, 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 3 blanks, states that the sum of the measures of the 3 angles in a triangle is always 180 degrees. Well, that is the angle sum theorem. So the angle sum theorem states that the sum of the 3 measures in any triangle is always going to be 180 degrees. So that's like saying angle 1 plus angle 2 plus angle 3 equals 180 degrees. Okay, that's going to come in handy for our next couple of questions. So number 9, find the measure of the missing angle. Well, we know that all 3 of them together have to add up to 180 degrees, right? So I could say 47 plus 16 plus x equals 180 degrees. Now I have some like terms here. My like terms are 47 and 16, and they're both positive, so I'm going to add them together. 47 plus 16 is 63, so we have 63 plus x equals 180. Now to get that x by itself, I need to subtract 63 on both sides. My 63's cancel out, x is by itself. 180 minus 63 is 117. So x is equal to 117 degrees. Okay, let's look at number 10. Number 10 is very similar. Find the measure of the missing angle. So it looks like I'm missing 2 angles, but remember, whenever you see this little square right here, I want you to recognize that that's a 90-degree angle. So even if you have to write that in, that's 90 degrees right there. Do that, okay? So we're really just missing 1 angle measure here. So we know that 64 degrees plus 90 degrees plus x equals 180 degrees. So now I'm going to combine my like terms. 64 plus 90, when I add those together, I get 154. So 154 plus x equals 180 degrees. Now to get that x by itself, I have to subtract 154 on both sides. So my 154's cancel out. X is indeed by itself. And 180 minus 154 is 26. So x equals 26 degrees. Okay, moving on to numbers 11 and 12. So this time we're going to solve for x. So in number 11, I'm given 2 angle measures, but then I've got this expression 9x plus 10 for my third angle measure. So I've got to solve for that x. So the way I'm going to set this up is 9x plus 10 plus 72 degrees plus 44 degrees all equals 180 degrees, right? Now I have some like terms. Anything that's just a plain old number, I can go ahead and combine. So we have 10 plus 72 plus 44. 10 plus 72 plus 44, when I add those together, I get 126. So we have 9x plus 126 equals 180. Well, to get that x by itself, first I need to subtract 126 on both sides. So my 126's cancel out, leaving me with just 9x equals, And 180 minus 126 is 54. Now, to get x by itself, it's connected to 9 through multiplication, so we divide by 9 on both sides. My 9's cancel out, and x equals 54 divided by 9, which is 6. So x equals 6 is my answer. That is the value of x. Okay, moving on to number 12. It's very similar, but this time I have 3 expressions. So I'm going to add all 3 expressions together. So 11x minus 3 is where I'm going to start, plus 13x minus 8 plus 7x plus 5. And all 3 of those expressions together have to equal 180 degrees. So now let's combine like terms. Let's start with all of our x's. So we've got 11x plus 13x plus 7x. Well, all together, that's going to be 31x. So I have 31x. And then everything that I haven't highlighted on that side are just plain old numbers. So negative 3 minus 8 plus 5. When I combine those, I get negative 6. So 31x minus 6 equals 180. So now this looks like a 2-step equation that you can solve. We start away from our x first. So I'm going to add 6 on both sides. My 6's cancel out, leaving me with 31x equals 186. Now to get that x by itself, I need to divide by 31 on both sides. My 31's cancel out, and x equals 6. Okay, let's move on to number 13. So number 13, we're going to check 2 terms to classify the triangle by its angles and sides. Okay, so classifying by angles. Well, remember, acute means all of them are less than 90 degrees. All 3 angles are less than 90 degrees. Obtuse means one angle is greater than 90 degrees. And right means that one angle equals 90 degrees. Okay, so these 3 terms classify by angles. And that means that these 3 terms classify by sides. Okay, so scalene means all sides are different lengths. Isosceles means that 2 sides are equal in length. And equilateral means that all 3 sides are the same length. Okay, so what I know is that this square right here means that that angle is 90 degrees. And there's a word that means that we have an angle that is exactly 90 degrees. It's right. So I know that this is a right triangle. And then these little markings here tell me that those 2 sides are the same length. So I have 2 sides that are the same length. So isosceles. So that is a right isosceles triangle. Okay, let's look at the next one. So we're given 2 angle measures. We don't know the third, but I can easily figure it out. How can I figure it out? Well, same thing that I was doing in numbers 9 and 10, the angle sum theorem. So I know that that could be my x. So we have 48 plus 32 plus x equals 180. 48 plus 32 is 80. So we have 80 plus x equals 180. I can subtract 80 on both sides. So I know that x equals 100 degrees. So that missing angle measure right here is 100 degrees. So we have a way to classify an angle, or classify a triangle, when we have an angle that is greater than 90 degrees. We have one angle that's greater than 90 degrees, so that means it is an obtuse triangle. Okay, now we've got to classify by sides. To classify by sides, I notice I don't have any markings telling me that anything is equal, so this is a scalene, a scalene triangle. All 3 sides are different lengths. Okay, now I'm looking at C, and the first thing I notice is that all of my sides are the same length. So we call that an equilateral triangle, when all 3 sides are the same. And I also noticed that all of my angles are pretty small. So they look to be acute. They look to be less than 90 degrees. And I want you to remember, equilateral triangles are always acute. So equilateral triangles are always acute. You will never have an equilateral triangle that is obtuse or right. They will always be acute. Okay, let's move on to number 14. Use an inequality to determine if the following side lengths could form a triangle. So remember the triangle inequality theorem, the two smaller sides have to be greater than the longer side. Okay, so the two smaller sides are 5 and 7. So 5 plus 7 is greater than 11. Well, 5 plus 7 is 12, and 12 is greater than 11. That is a true statement. So yes, this forms a triangle. B, my two smaller sides are 9 and 15. So I'm going to add them together. So we have 9 plus 15 is greater than 26. Well, 9 plus 15, and when I add those together, I get 24. So 24 is greater than 26. That's not a true statement. The way I just read that, 24 is greater than 26. Not true at all. So these do not form a triangle. And then the last one right here, 22 and 28 are the smaller sides. So 22 plus 28 is greater than 50. Well, 22 plus 28, when I add them together, I get 50. So 50 is greater than 50. Let's read that again. 50 is greater than 50. No, 50 is equal to 50. So that's not true. So these cannot form a triangle. So that is the end of our practice review. Good luck on your quiz tomorrow.